Okay. So today we are going to start a new topic. Till now we have studied about work done by spring and work done by variable forces, constant forces. Now we start a new topic called power. So when we talk about power, suppose there are two people. Let's say there are this person A and this person B. This person A does same work. Let's say any work, kind of work, same work he does in 10 minutes. And this person B does in 2 minutes. They are doing same work. Work is same. It is not different. But who we say is more powerful? Person A or person B? If a person takes less time, more time in doing the work or less time in doing that same work, who we say is more powerful. So the person who is faster, we say that he is more powerful, and who is faster, who does it in less time, then we say that this person is powerful. Person B is powerful than person A because he does the same work in 2 minutes, but person A takes 10 minutes to do it. So when we talk about power, we don't consider only work. We consider time as well. That how much time it take to do that work. So that's why the definition of power comes that power is the rate of doing work. That in how much time the person is doing that work. Power is the rate of doing work. If a person does same work in less time, then he is more powerful. If it takes more time, he is less powerful. How we say in our general daily life. So that's why the power is the rate of doing work. And we get the formula as power is equals to work upon time. We can also write power as P, work as W, time as T. So power is equals to work upon time. Here we get the formula of power. Now we will talk about the SI unit of power. What is the SI unit of power? Unit of power. So to find out the SI unit of power, we see the SI unit of work and SI unit of time. So SI unit of work is joule, and SI unit of work is joule, and SI unit of time is second. So SI unit of power comes to joule upon second, that is joule per second, and we call it altogether watt. We represent it with W. So watt, that is W, is equals to joule upon second, and we write it joule as J and second. So W, that is watt, it is unit, is equals to joule upon second. So SI unit of power is watt. Although we in our daily life we generally don't use watt as unit, like it is a smaller unit. In our general daily life, we use other units like kilowatt, like kilowatt or horsepower. So 1 kilowatt, we write it like kW, kilowatt, is equals to 1000 watt. and 1 horsepower, we write it as HP, is 746 watt. We can see that where horsepower is used. So this horsepower is generally used in as unit in like car engines or motors. In these kind of thing, we use horsepower as unit. And for electricity, that is like what we get in our home, the electricity, we use kilowatt. In our daily life, when we say that there is 1 unit of electricity, 1 unit of electricity, it means that it is okay. There is one more thing, which is just a minute. Okay. There is one more thing is our electrical energy that comes in our home. We write it as 1 kilowatt hour as energy. 1 kilowatt hour is energy. Not it is not a unit of power. It is energy. We write it as 3.6 into 10 ki power 6 joule. So, in our home, that 1 kilowatt hour, it means 1 unit of energy of electricity means 1 unit. And this 1 unit of energy means 3.6 into 10 ki power 6 joule. This much energy consumes, then we say that it consumed 1 unit. So, if we want to solve a basic question, very basic question, that if a person does 100 joule of work in 10 seconds, then find out power. How can you find out? We write the formula of power. Formula of power is work upon time. How much is work? 100 joule. 100 upon how much is time? 10 seconds. 10. So we get 10 watt. I have told you that unit of power is watt. SI unit of power is watt. And this is joule, this is second. So the SI unit will be watt. So power comes to 10 watt. This is the basic concept of work. Is there anyone? Okay, that's fine. We go ahead with our next topic. Okay. Now our next topic is kinetic energy. Our next topic is kinetic energy. You have came across this term kinetic energy. You might know what is kinetic energy. I'm explaining it for you so that you understand it very clearly. So, energy means capacity to do work. Energy means, this word energy means capacity to do work. So, it means capacity to do work. That's why the unit of work and unit of energy is same. Unit of work is joule, unit of energy is also joule. It's only like its capacity to do work. So sometimes we use it interchangeably, although in scientific terms we should not, but to solve questions, and since the definition itself says it is the capacity to do work, it means there is similar kind of thing for this. So we used it interchangeably. If an object can do work, it means that it has some energy. Without energy, anyone cannot do any work. To do work, we should have some energy. Let's say, um, moving car can push another car. Moving ball can break glass. It means it has some energy to do the other work. So all moving object, all moving object have energy. That's why it is moving. Without energy, any object can't do any work. So all moving object have energy, and this energy due to motion is called kinetic energy. The energy due to this motion, if a car is moving with some speed, so this car must be having some energy. So energy due to this motion is called kinetic energy, and we can call it, like, if I'm saying about car, we can say that this is the kinetic energy of car. So all moving objects have energy, and this energy due to motion is called kinetic energy. We can also say kinetic energy is the energy possessed by a body due to its motion. It's just another way to say it. It's all about that if something is some object, or something have some velocity, some speed, some motion, then it must be having the kinetic energy. And this kinetic energy is because of that motion. So it's all about motion. Since it's all about motion, we there is certainly some relationship between kinetic energy and velocity. So that we can see from the formula. So formula of kinetic energy is, we can write it. Let's say I'm writing formula. So I'm writing kinetic energy as Ke is equals to half mv squared. This is the formula for kinetic energy. So from here we can see that there is a relation between kinetic energy and mass. There is a relation between kinetic energy and velocity. So from here, we can see that kinetic energy is directly proportional to mass, and kinetic energy is directly proportional to velocity ka square. Now there is one thing, that what are the possible values of kinetic energy? Okay, before going ahead, I should write m is mass of object and v is speed of that object. Now we can see from here, from above, that all the topics that we have studied earlier, we have seen that work can be positive, can be negative, or zero. But here we can find out that whether kinetic energy can be negative or not, or it can be positive or not. We will see that. Now to see that, we will see the formula. The formula is half mv square. Now half is positive. Mass will be always positive. We can't say anytime that it is minus 2 kg. It can't be possible. There is velocity, or we can say it is speed. This value, whatever this value is, it is a square. And whenever we take square of any value, it will be positive. So it is also positive. So we can say that it is also positive. All the things are positive. It means that kinetic energy will always be positive. Always positive. It can't be negative in any condition. It will be always positive. And it depends on mass on square of speed. So one thing is this kinetic energy will always be positive. And there is second concept. Let's say I increase uh, the speed by doubling it. Let's say if there is a concept, if speed becomes double, what? Sorry, just a minute. Okay, I'm saying that if speed becomes double, what happens to kinetic? Oh. Hmm. Hmm. If speed becomes double, what happens to kinetic energy? So we can see it from the formula. What I'm saying that speed is double. So initially, let's say I'm saying it kinetic energy one is half mv square. Now what I am doing? Kinetic energy 2. In this case, what I am doing? Doubling the speed. So half is as always, and mass is not changing. What happens to this is it is double. It means 2v. Double of v is what? 2v, and it's a square. So what it becomes? Half into m into 2v square, 4v square. It comes to 2mv square. Now, what happens to kinetic energy is we have to find out how much times it is of the previous one. So, what we will do, we will divide it. K1 upon kinetic energy 2 is equals to half mv square upon 2mv square. This cancel out with this, and what we get is 1 upon 4. So kinetic energy, now we will do the cross multiplication. This comes here, 4 comes here. Kinetic energy 2 is equals to 4 into kinetic energy 1. So what happens to kinetic energy? It becomes 4 times of the initial kinetic energy. What it became? 4 times of the previous kinetic energy. This happens when we uh, change the speed to the double. If I double mass, let's say second is if mass doubles, what happens to kinetic energy? What happens to kinetic energy? So again, we are doing same thing. Kinetic energy 1 is equals to half mv square. Now in kinetic energy 2, what I'm saying that mass is double. So in place of 2m, I will write 2m into v, same for this case, v square. So now 2 cancel out with 2, m v square. So we can see that now I divide kinetic energy 1 with kinetic energy 2. So half mv square upon mv square. So this cancel out with this. We do cross multiplication. Then we get kinetic energy 2 is equals to 2 times of kinetic energy 1. So if we double the mass, kinetic energy will also be doubled. So you can see that if I double speed, it became 4 times, and if I doubled mass, it became 2 times. And this is I solved it properly so that you understand each and every step. Now you can also see it from here, that it is directly proportional to mass and proportional to v square. From here we can see that kinetic energy, if I double mass, it is 2m. So directly doubles. If I double velocity, kinetic energy directly proportional to let 2v square. So we can write it like 2 into 2, 4v square. So you can see that this is 2 times, this is 4 times. So if we want to see shortly, we can see it from here. And if there is a question that asks okay, what happens when I double the speed, then you should solve like this. So yeah, this is the concept for the if what happens when we change the speed and mass. Let's say solve the basic question. Let's say there is a question that a body of mass 2 kg moving with speed 5 meter per second, then what is its what what is its kinetic energy? So to solve this, we should simply apply the formula, that kinetic energy formula is half mv square. So what is mass of that body? 2 kg. 2. What is velocity? 5 meter per second. So 5 is square, half into 2 into 5 square is 25. 2 cancel out with 2, 25. And what will be the unit? Joule. I have said it earlier that energy is, I have said it here, capacity to do work. It means that a unit will be same. And if this is the concept that where we get the unit, and if you have any doubt that how it is same, you can put put unit of mass and velocity square, and you can find out that how it is same. So its unit is joule and 25. So this comes the kinetic energy. Now we go ahead with our next topic. Our next topic is work energy theorem. Very important topic. Work energy theorem. Okay, what happens when a force acts on a body? It changes its speed. Change in speed means change in kinetic energy. Let's say there is a block and it is just placed on the horizontal surface. And if I apply some force here, what happened? Its speed changes. Initially, its speed is u, and if I force it towards left, it will go ahead and it will have some energy when it comes like here. It have some energy v, some velocity v. So we can see that force changes velocity, and if velocity is changing, then kinetic energy will also change. Here, kinetic energy is zero because speed is zero. Here, let's say it's m mass. Here, speed is v, so kinetic energy will be half mv square. So when we apply force on our body, it changes at speeds, and when speed is changing, the kinetic energy will also change. So that's why there is a relation between work and energy, and like work done by that force and energy. So, what, how it is related to kinetic energy? How work done by this force is related to kinetic energy? So, the theorem says the work done by net force on the body, net force on this body, is equal to change in its kinetic energy. Okay, it is not saying about only this force work. It is saying about all the forces that are acting on this body. Net work done, work done by net force on the body is equal to change in its kinetic energy. Since other forces like mg and normal, uh, when I solve it, it became cancel out, and the effect of these forces will comes out to zero. It doesn't mean that it is not counting. It's just that it becomes zero because of the other forces. But we have to always take the net force, and work done by that net force is equal to change in its kinetic energy. So what um, work energy theorem states that the work done by the net force on a body is equal to the change in its kinetic energy. So how we write? We can write it like work done by all the forces, basically work done by the net force is equals to change in kinetic energy. Change means final minus initial. So kinetic energy final minus kinetic energy initial. This is the theorem, work energy theorem. Work done by net force is equals to change in kinetic energy. So I'm writing this. W is work done by net force. KEF means final kinetic energy and KEI is initial kinetic energy. So this is the formula for work energy theorem. Now, let's say I am taking an example so that you understand it very clearly that what is happening. I'm explaining it with an example. Let's say let example with the numerical. There is mass of object 10 kg, initial speed 4 meter per second, force 30 Newton, time 2 seconds. Let's say there is this block, there is 30 Newton forces applying. Its initial velocity, we represent it with U, is 4 meter per second in this direction, and mass is 10 kg, and time that we are taking is 2 seconds. So since all other forces are cancelling out, net force is only this. There are no other net force. That's why we are taking only this force. Now, first of all, we need some things like to to find out this, to find out work done by this force. What we need that first is what is, let's say write it again. Work is equals to change in kinetic energy, Ke final minus Ke initial. First of all, we will find work. Let's say to find work, what is work? F into D, force in the direction of displacement and displacement. So in question we don't have displacement, we have to find it. So to find out that in time 2 seconds how much distance it has covered, we have to find out the acceleration. So first we will find acceleration. So how to find acceleration? By using Newton's second law. F is equals to mass into acceleration. Force is 30 Newton. Mass is 10 into acceleration. We do cross multiplication and A is equals to 30 upon 10 comes to 3 meter per second square. This is acceleration. We have find out the acceleration. Now by using this acceleration, we can find out how much displacement it has covered. So to find out displacement, we will use this formula. S is equals to ut plus half a t square. What is u? U is initial velocity, and we have given that initial velocity is 4 meter per second. So 4, what is time? Time is 2 seconds. 2 plus half into what is acceleration? We have find out 3 meter per second square. 3 time is 2 seconds. 2 ka square. 4 into 2 is 8 plus half into 3 into, we can write it's 2 into 2. 1 2 is cancel out with this. 8 plus 3 into 2 is 6. 8 plus 6 is 14. So displacement comes out with 14 meter. From here, now we can find out work. Work is F into D. What is force? Force is 30 Newton into what is D? 14 meter. 14 into 3, 4, 42, 0. So this is work done by this force 30 Newton. Unit is joule. So this work we get. Now we will find out this portion. Work we had find out work. Now we will find out this portion and then see whether it is equal or not, that the formula is true or not. So what we will find out, kinetic energy final, then kinetic energy initial. Okay, to find out kinetic energy final, what we need? Half. Mass is not changing, so mass is constant m into v f square. The speed, final speed, square of final speed. Speed is not same everywhere, so speed is final speed to find out final kinetic energy. So I don't have final speed as of now. So what I am doing, I am again using formula to find out final speed. So for this, I am using v is equals to u plus at. V, that is V final. I'm writing is that V final is U. What is U? Initial velocity, 4 meter per second. Don't write unit here. We will write unit at the end. 4 upon plus. Acceleration is 3 meter per second square and time is 2. So it comes to 4 plus 3 into 2 is 6, 10. So it comes to 10 meter per second. Vf is 10 meter per second. So I get it. Now I can find out kinetic energy final. Half mvf square. Half m is 10 kg. 10 into vf final is square of 10. This cancel out, gets 5. So 5 into 100 and it comes out to 500 joule. Now I have to find out kinetic energy initial. What is initial kinetic energy? Half into m into initial velocity, and I have said it as u, initial velocity, k square. Half, mass is 10 and initial velocity is given as 4 square. This cancel out, gets 5. 5 into 4 into 4, 16. 16 into 5 is 80 joule. Now we will find out kinetic energy final minus kinetic energy initial. Is final is 500 joule. Initial is 80 joule. When we minus it, what we get? 420 joule. Now we can see that kinetic energy final minus kinetic energy initial comes to 420 joule. And what we get work done by the force? 420 joule. Now you can see it is equal. So this is work energy theorem, that work done by net force is equals to change in kinetic energy. Kinetic energy final minus initial. You have to remember this work energy theorem to solve the questions. It is very important topic, and this is all. This is the explanation that I have teach you through the numerical, and yeah, now I hope you can understand it, that work done by net force is equals to change in kinetic energy. This is the concept. Now we go ahead with our next topic. Our next topic is potential energy. Potential energy. Um, so sometimes an object is not moving but still has energy. Whatever we have studied in this kinetic energy and this work energy theorem, in this we have studied that if object is moving, it must have some energy. So it's all about the moving object. But if something is not moving, if sometimes an object is not moving, even then it has some energy. It doesn't mean that it has no energy. So, for example, water is stored in dam or book kept on the table. This kind of a thing has some energy. For example, water stored in a dam or book kept on the table. It doesn't mean that it has no energy. It has energy. Even it is not moving, that water is not moving, that book is not moving. Even if it is not moving, it has some energy. And this energy, due to its position, is called potential energy. This energy is due to its position, and we called it as potential energy. Now we go ahead with gravitational potential energy. What is gravitational potential energy? When a body is lifted against gravity, let's say it is ground level, and here a block is kept, and uh, we hold this block and raise it to this height. So when a body is lifted against gravity, what we are doing? We are lifting it against gravity. Gravity is downwards, and we are lifting it against it. So when a body is lifted against gravity, work is done. There are some force and some work done by me by when I hold this object and place it to some height. This work is stored as potential energy in this block. This work is stored as potential energy. So we can write it when gravitational potential energy. So when a body is lifted against gravity, work is done. This work is stored as potential energy. So in this case, the potential energy comes to if let's say this I have kept this ball at height h, and I am working against this gravitational energy. So if let's say I'm not changing its speed or anything, I'm just working against the gravity. So I must pull out with some force, and it should be like mg. I am working against it. Let's say what is here the work done by gravity. Work done by gravity here, done by gravity here. What is this? Force into displacement. Force into displacement. What is force? Downwards mg. And what is change in displacement? It is upwards h. So here 180 degree. So what is force? Mg. It, okay, I'm writing it very clearly. It comes to Fd cos theta. Theta is angle between force and displacement. So F is mg, d is displacement, cos angle between force and displacement is 180 degree. mgh cos 180 degree value is -1. So it comes to minus mgh. Now I'm saying that I am working against gravity. So if I'm working against gravity, that is I am doing the same work but against gravity. So the magnitude will mgh done by me. And since I'm doing against it, it means if it is negative, mine should be positive. And this work that I have done is stored in this block as potential energy. So the value of this potential energy and this will be same. That's why we comes to the formula potential energy is equals to mgh. And this is gravitational potential energy. In this, m is mass, g is acceleration due to gravity, h is height above reference level. Above reference level. Okay, what is reference level here? I am taking reference level as ground. So if I'm taking reference level as ground, the what happened? Hmm. If I am taking reference level at ground, what happened? That reference level means the potential energy at this point, the potential energy at this point is zero. That's what reference level is. So potential energy here, if I'm taking it as reference level, is zero. You can take anywhere your reference level. It's all about change in displacement, like change in position. If I'm taking reference level here, I'm taking change. So you can take anywhere, but generally, what we try to solve it, we generally do take ground as reference level to make calculation easy. You can take it anywhere, and you have to do that potential energy at that level is zero. But generally, we use ground as reference level. So yeah. We use this, but we can like do it anywhere because what matter is change in height, not absolute height. So there is no problem if I'm taking anywhere else. Okay, so let's solve a simple question. Let's say an object has mass 2 kg and it is lifted, and it is lifted to height 5 meter. What will be the potential energy? So it is very easy. Just put the formula. Potential energy is equals to mgh. M is 2 kg, G is 9.8, H is 5. So when we multiply it, 5 into 2 is 10, and when multiply it by 10, 98. So 98 joule. This is the potential energy. Now we see the change, the relationship between kinetic energy and potential energy. Now we see the relationship between kinetic energy and potential energy. Okay, let's take the example of a ball that we throw in the air. Let's say there is a ball we throw in the air with initial velocity, let's say 2 meter per second. And this ball will go upward to some point and stop here and then comes back to its original position. Let's say it's its ground level. Okay, now at this point, what is its, yeah, this is ground level and I am taking this level as reference level. Reference level. So if I'm taking it as reference level, what is potential energy here? Potential energy here is, let's say I am taking it as 1 initial point, then it becomes 0 potential energy here. And if I have to find the kinetic energy here, then what comes? Kinetic energy. Kinetic energy, one is half mv square. So half, let's say mass is 2 kg. Mass 2 and velocity is also 2, then 2 square. So it comes to 4, means 4 joule. Means its potential energy here is 0, its kinetic energy is 4 joule. Now we will throw it upwards, and here the velocity at this point, let's say it is point B, the velocity at point B becomes 0. At the highest point, the velocity of the ball is 0. So it becomes 0. So at point B, if I'm taking it as B, let's say this point at A, and just name it as A. It's just for the ease, so that I can teach you easily. It's just naming. Okay, so now I'm here. So for point B, for point B, kinetic energy V is equals to half m v square. Now you can VB, let's say. Now you can see that here velocity is 0. So it is 0, and anything multiplied by 0 is 0. So kinetic energy here is 0. Now we will find out the potential energy. Potential energy is mgh. M is mass, G is acceleration due to gravity. What is h? H is this height reached by the ball. H is the change in position from here to here. So this is h. Now, for now, we don't know value of h. So what we will do, we will find out the value of h. To find out value of h, we use the formula v square is equals to u square plus 2as. This s is displacement and we are writing it as h. So what is v? V is final velocity. For now, final is this. It is 0. U is initial velocity. It is 2. So 2 square plus 2 into acceleration. What is acceleration here? Acceleration is gravity. Only gravitational force is applying here. So acceleration is gravity. So acceleration due to gravity is g. So just write g here. And I have to find out h. Now 0 is equals to 2 into 2 is 4 plus. Now, what is value of G? It is downwards, so there is a negative sign, and value of G is 9.8 into H. Now, keep this on the left hand side. Minus 4 is equals to minus 2 into 9.8 into H. So, from here, you can see that H is equals to, this might cancel out with this. Just wait a minute. Mhm. So, okay, this H comes out to, just do cross multiplication, 4 upon 2 into 9.8 into H. Sorry, 2 into 9.8 only. Okay, what I'm doing, I'm just leaving it here, the value of H, so that I there is, okay, just simplify it little bit, then we leave it. This cancel out with this, so we get 2 upon 9.8. Now, if I am why I am leaving it here, because if I am I will solve this, this comes out with some fraction only. So I will do overall calculation at later stage, so that it will be easy. So I get height. It is the height. We can simplify it, but it is the height. Okay, now we will find out potential energy at point B. What it is? mgh. Mass is 2 kg. What is G? Value of G? 9.8. What is H? 2 upon 9.8. Now you can see why I have left it here, because I know that it will get cancelled out with this. So why I will waste my time on calculation? So I can get 2 into 2 is 4 joule. So one thing that I want you to see, that here potential energy is 0 and kinetic energy is 4 joule, that at this level, this reference level, and at this point, this B level, the kinetic energy becomes 0 and potential energy becomes 4. We can see that kinetic energy get decreased to 0 and potential energy get increased to 4. From here, we can also see that we have studied earlier in our early classes, that energy can't be destroyed, can't be created. Energy is conserved. So what we are seeing is, when kinetic energy is decreasing, at the same time potential energy is increasing. That the sum of kinetic energy and potential energy will always be constant. The total energy always remains same. The total energy, if I find out total energy at point A, what it will be? Kinetic energy at A plus kinetic energy, plus potential energy at A. What is kinetic energy at A? 4 joule. What is potential energy at A? 0. So it comes to 4 joule. Now, second is total energy at point B, kinetic energy at point B plus potential energy at point B. Kinetic energy is 0 at point B and potential energy is 4. So it comes to 4 joule. You can see that total energy is same. So total energy will always be same. If there is no loss of energy because of friction or anything, in ideal case, total energy will remain same. And what happens in moving upward? When an object is moving upward, in upward motion, I'm writing it here. I'm writing it here. In upward motion, kinetic energy will decrease and potential energy will increase. Okay, why kinetic energy decreasing? Because when ball go upwards, it decreases. The velocity of the ball gets decreases. That's why kinetic energy is decreasing, and height is increasing. That's why potential energy is increasing. In downward motion, in downward motion, what happens? Kinetic energy will increase and potential energy will decrease. Okay, when this ball goes again comes to downward, what happens? Here at B point, its velocity is zero, but when it comes down, its velocity will again increase. So the kinetic energy will increase and the potential energy will decrease because of the decrease in the height of this ball in downward motion. That's why it is like this. So this is the relation between kinetic energy and potential energy. And from here we can see that sum of kinetic energy and potential energy, that is total energy, is same for both the case. It means total energy will always be same. It means that total energy remains same. Now, after this, we will study in next class about this in elaborate way, that how total energy will be same and other things. This is what conservation of energy is. We will study in next class about more about this topic. So yeah, today we have studied about kinetic energy, work power theorem, power, and potential energy. So these are the topics you should study from the book and try to solve questions. Yeah, that's it for the class.